Given that the majority of patients with follicular lymphoma will relapse and almost 10% have refractory disease, the need for additional therapies is apparent. Further complicating the management of these patients is the 2 to 3% annually who may experience histologic transformation to diffuse large B-cell lymphoma. In an effort to move beyond anti-CD20 antibodies and PI3K inhibitors, new areas of B-cell biology have been investigated. Discovering that the aberrant upregulation of enhancer of zest homolog 2, or EZH2 activity, is oncogenic in a broad spectrum of human cancers has led to the clinical development of tazometostat. EZH2 is the catalytic subunit of the chromatin remodeling polycomb repressive complex 2, or PRC2. As a selective inhibitor, tazometostat has been shown to antagonize mutant EZH2 activity in patients with tumors. It does so as an epigenetic therapy for cancer. Epigenetics begins with DNA and histone proteins that are functionally intertwined in chromatin. The basic chromatin unit, the nucleosome, is made up of 146 base pair segments of DNA wrapped around a core of 8 histone proteins. DNA and histone proteins are modified in ways that regulate both function and accessibility. EZH2 is an enzyme that regulates the post-translational epigenetic modifications on histones through chromatin function regulation. It is characterized as a writer, meaning that it adds modifications. Tazometostat inhibits the mutation-driven overexpression of EZH2 and halts the modifications in the form of methylation that can drive mutagenesis. With EZH2 activity inhibited by tazometostat, the lock on B cells in the lymph node germinal center is released, allowing the B cells to differentiate and move out to the periphery. This move to the periphery in the form of either a plasma cell or a memory B cell continues the normal, non-malignant fate of the cells. Crosstalk between the processes of epigenetics and immunomodulation has been highlighted in studies. EZH2 places repressive marks, leading to downregulation of major histocompatibility complex, or MHC, class II genes that might dampen the anti-tumor immune response. EZH2 has also been implicated in activation and maintenance of regulatory T cells that suppress the immune system. In addition to its effects on B cells, EZH2 controls mechanisms of adaptive resistance to tumor immunotherapy. Specifically, investigators found that intratumoral TNF-alpha production and T-cell accumulation promote EZH2 upregulation in melanoma cells, resulting in a loss of immunogenicity and antigen presentation. Additionally, the loss of CD2-CD58, an important intercellular signaling pathway for the immune reactions in cytotoxic T and natural killer cells against tumor cells, is one of the most frequent mechanisms of immune escape in lymphoid malignancies.